We are here trying to solve previous year KTU problems. This is for exam preparation. So this is a question from 2017. This is from module 5, stress transformation portion. This was a KTU problem asked for 5 marks. So there is 2 parts to this question. First part is for 5 marks and second part is for 15 marks. Okay. So first question is explain principal planes and principal stresses. An ideal answer will look like this. We don't have to, if you remember these formulas and all, it is better to write answer like this. Otherwise, the last part of the solution also is enough. Okay, but this, if you write like this, you're 100% sure that you're going to get the maximum marks. Stress at any point is indicated using a stress block. Normally we indicate stresses at any point using stress block. Stress block is basically used to do that. Stress block can be 3D or 2D. We are dealing with only 2D stress block. It gives stresses in mutually perpendicular direction. So basically it is giving you stresses at the point in two mutually perpendicular directions. So it is indicated like this: sigma x is the stress in x direction, sigma y is the stress in y direction, and we have a shear stress. Okay. Now if you rotate the stress block by some angle, we will get a new set of stresses. Okay. So the new set of stresses can be found using old values of stresses by using what is known as equations of transformation. So this transformation equation is given there. The student is expected to remember these 3 equations from this portion for exams. Okay. So sigma x1 is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So sigma x, sigma y and tau xy is the stresses in the normal orientation, and this is the stresses in the sigma x1, sigma y1 and sigma x1, y1 as the stresses in the rotated orientation. Okay. So this, there is a plus. If you put a minus here, you will get sigma y1. Tau x1, y1 is sigma x minus sigma y by 2 sin 2 theta. So cos becomes sin with a negative sign here. Then this form, this part also will come here, tau xy cos 2 theta, sin will become cos. So sin and cos will change and there will be a negative here. So that will become tau x1, y1. So these 3 formulas you are expected to remember. So if you are not able to remember, recollect these formulas, you have to answer. So this is the last most important part of the problem. So basically, if you keep on rotating, you will get some plane, some rotation, some angle in which there is no shear and there is only axial force. Okay, axial stress. There exists a particular set of plane in which the shear stress is 0 and normal stresses are maximum minimum. Those planes are called principal planes, and normal stresses on those planes are called principal stresses. So principal stresses are stresses on the principal planes. And what are the principal planes? Principal planes are basically planes in which shear stress is 0. Okay. And how do you find the values of those principal stresses? Using this formula: sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square tan 2 theta p, the plane, the angle of orientation of the principal plane. So this orientation can be found by tau xy by sigma x minus sigma y by 2. Okay. So this is how you answer this problem. If you are not able to recall this part, this much if you write, then also it is fine. But if you write the entire thing, it's a sure shot 5 marks. Then this is the second part for 15 marks. It is very easy part. 15 marks you can score very fast. So it is telling a point is subject to a tensile stress of 60 MPa and a compressive stress of 40 MPa acting on 2 mutually perpendicular planes. Right? So they are telling there are 2 planes, 2 mutually perpendicular planes, and there is 2 stresses acting on the plane. 2 normal stresses acting on the plane. So first stress is in this direction. So this is 60 MPa in tensile. So remember, 1 MPa is 1 Newton per mm square. You should remember this. Okay. And then the perpendicular direction, there is compressive stress of 40 MPa. Then there is a shear stress of 10 MPa also acting on the plane. So shear stress, which direction? In direction you can draw. So first you draw one direction, one plane. So this is 10 MPa. Once you draw one shear stress, the other shear stresses you can automatically draw. How? So this block, it should be in vertical equilibrium. So you need a shear stress in this direction. So whatever shear stress is there, same shear stress will act in this side, so that the block is in vertical equilibrium. Now this block has a tendency to rotate in anti-clockwise direction. To prevent that, there should be a shear set of shear in this direction. Okay, so these two shears is what is known as complementary shear stress. Okay, so these are coming to create equilibrium. This is there to create equilibrium. Now all the values we got, we know that sigma x is plus 60 MPa. So plus because it is tensile, that is a convention that we are using. Sigma y is minus 40 MPa. So again negative because it's compressive, that is a convention. Tau xy is 10 MPa. So there is a sign convention for shear also. We are not getting into this because as per our formulas, the sign of the shear doesn't matter. Okay. Now we can find the principal stresses using this formula. Sigma 1, 2 can be found by sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, so sigma 1, we'll get two values, one use plus, the other we use minus. The larger value we give sigma 1, it's a convention. A smaller value we will call as sigma 2. Okay, so if you substitute, what do you get? Sigma x is 60 minus 40 by 2 plus minus under root 60 plus 40 by 2 whole square plus 10 square. So one mistake that everyone does is using the sign. Okay, so we have sigma x minus minus will become plus. So this becomes 60 minus 40, 20 by 2 is 10 plus minus. So this entire value comes out to be 51 MPa, approximately 51 MPa. So I can say my sigma 1 is 61 MPa and my sigma 2 is 10 minus 51 is minus 41 MPa. Okay, so this is the first part. Determine the principal stresses. That's all. That's the first part we have solved. Then it is asking you what is the maximum shear stress. The maximum shear stress is given by this portion. This portion is the maximum shear stress. Okay, so that is sigma x minus sigma y by 2 whole square plus tau xy whole square under root. So this is nothing but 51 MPa. So this is actually minus plus minus, we can say plus minus 51 MPa. So this is a tau max. So I hope this is clear. This much only you have to write. This is only what they are asked. You can also give principal plane if they ask on some other problem. Tan 2 theta p is given by tau xy by sigma x minus sigma y by 2. Okay, so this gives me 10 upon what is this? Sigma x minus sigma y by 2 is 10. So that is 1. So 2 theta p, tan 2 theta p is 1. So 2 theta p is 90 degree. So this gives me theta p is equal to 45 degree. It's plus minus. Okay, 45 degree. So you can orient in plus direction. Plus we will say counterclockwise. Minus we will say clockwise. So once if you draw a stress block, then your answer will be complete. So this portion, the theta p portion, you don't have to answer for this problem, but I'm just answering for your knowledge. Okay, so we have a 61 MPa tensile here, and we have a compressive stress of 41 MPa. Okay, so this is MPa. This also MPa, and this angle, you can write this angle as 45 degree. 45 degree. Okay. Now this is the final stress block. There is no shear stress. That is why it is called principal stress. There is no shear stress in this plane. Okay. Now shear stress maximum is in some other plane, so that we will not answer now. Maybe we will take up some other question in which it is there. Okay. So that's all. We will take up another question later. Thank you.